Hello and welcome to Golden Geography. Today we're going to be thinking a little bit about Earth's life support systems for the OCR Geography A-level specification. We're specifically going to be focusing on key question 2, how do the water and carbon cycles operate in contrasting locations? And for this video we're looking at key question 2b. That focuses on tundra. We're going to talk a lot about Arctic tundra, but just be aware you can have alpine tundra too. Arctic tundra is found in cold areas near the poles, so predominantly in the northern hemisphere. It tends to be a treeless biome because the ground is frozen, it's got permafrost, so trees can't get their roots deep enough into the ground, so there tends to be a lack of trees. We are looking at Alaska, northern Canada, parts of Siberia in northern Russia. Areas that have very cold temperatures, they have frozen or permafrost ground, low levels of precipitation, and very often very dark periods, long extended dark periods, short summers with the 24 hours of daylight. So we're going to look at question 2b. We're going to focus just on the theory here. There is another video available on the case study, so do look at that specifically. You might find that you have case studies from different areas. Mine will be on Alaska. There are also lots of synoptic links here with both glaciation and oceans. A little bit of powers and borders too, so look out for some of those links. We're going to start thinking a little bit about the Arctic tundra in terms of its flows and stores. So if we think a little bit about the water cycle particularly, it has quite distinctive stores. The flows between those stores are relatively low. So there's low level of precipitation, it's very cold, so there's very little evaporation. Because there's very little evaporation, there's very little precipitation. If nothing goes up, nothing comes down. So we've got low levels of precipitation, and what does fall out of the sky will tend to be in the form of snow rather than rain. We do have plants, but their growth is very seasonal, very much in the summer 3 months. So transpiration levels are low, so low flow rates there, or processes rates there. Runoff varies most of the year, very little, but in the summer it can be quite high because of changes in temperature. Infiltration tends to be low because of permafrost and low permeability, and limited groundwater flow, particularly in those winter months. When we think about the stores of our water are quite distinctive. We have permafrost, which is basically permanently frozen ground, and you can see some images of it here. If you dig down into the ground, you will find that it is frozen. In winter, all of it will be frozen. In summer, the top 10-15 centimetres or so is called the active layer. That might melt and refreeze, and it has a seasonality to it. But even in the summer, beneath that active layer, you will find permafrost, permanently frozen ground, and that's part of its definition. It has to be frozen year in, year out for an extended period of time, and it is a big store of water. It holds a lot of frozen water for long periods of time, often formed during ice ages, but found in what we call periglacial areas next to glacial regions. We do have soil moisture that's found in the active layer. In the winter it's frozen, in the summer it melts. We will get surface water, particularly in the summer when the active layer melts. We have much higher levels of surface water. There is some evaporation into the atmosphere, again tends to be in the summer, and there is some vegetation that you will use some of the water, but not much, and it's quite a slow process because of low temperatures. Carbon cycle similarly is quite slow when you're talking about the flow rates, so photosynthesis will happen, but it's got a short growing season in the summer. Levels of light might be there all day, but they're relatively low levels of light. So photosynthesis is slow. Respiration similarly is slow. Decomposition can happen in the summer months, but it is slow because it's cold and it's dry. Very unlikely to get any decomposition in the winter. In the winter, these landscapes are covered with snow. There are things that are going on that will change. There's something called methogenesis, which is the release of methane, and that is going to have a big impact on the carbon cycle. It is changing because of climate change, and it is tied into these waterlogged soils. So there's a little link here between the carbon and the water cycle, and that really takes place in the summer period. Permafrost is key. Carbon is trapped in that permafrost. As it melts, it is released, particularly in the form of methane. So what are some of the physical factors that affect tundra, affect this environment? Well, if we're thinking a little bit about those, temperature is absolutely key. So cold temperatures, that means within the water cycle, those flows are slow. So very little precipitation. What there is snow. Evaporation and transpiration is limited because it's cold. Permafrost, permanently frozen ground, is present all the time. The active layer is frozen for most of the year. The flows do happen, but they happen slowly most of the time. Can happen quickly during spring and summer when we get rapid snow melt, but for short periods of time. Very much dependent on that spring and summer period. Carbon cycle, similarly, these cold temperatures keep the carbon cycle really slow. So decomposition is really slow. Photosynthesis is really slow. But because of climate change, these processes are starting to increase. Tundra is one of the most vulnerable biomes to climate change. And as the planet is warming, the highest levels of warming are happening in these tundra regions. They're getting the highest temperature changes, and that is causing the permafrost and the active layer to melt to release CO2, but also to increase those decomposition rates. And things that have been slowly decomposing are really increasing their decomposition, and that's releasing a lot more carbon in this particular environment than there should be naturally. We also have rock and rock variability. You've got all different types of geology there, but what is happening, and the key thing here, is that the permafrost changes the rock permeability. So that permafrost makes the rock impermeable. So in the summer, when the active layer melts, the water that was in the active layer, was frozen in the active layer, can't infiltrate because the permafrost is impermeable. So it creates these big lakes that you can just about see on the top of this picture here. You can see the permafrost beneath it, but you can see the lake developing on the top. So lots of boggy conditions develop in the summer. And it means also that there's very little groundwater flow, very little movement through the permafrost. And the carbon cycle too has limitations. The processes of weathering are slow, so the release of carbon from carbonated rocks is slow. Very restricted by the temperatures. Relief on the whole tends to be quite flat, but these areas, these tundra areas or periglacial areas, are right next to glaciated areas, so you will often see them next to mountains like you do in this picture. That flat relief that we have helps influence this boggy environment we just talked about. As that active layer melts, the water can't drain away because the land's quite flat, so it develops this boggy environment. These big lakes called thermokarsts and ELSS are found there. And it also means for the carbon cycle, water isn't kind of moving and flushing carbon away, it's just building up in situ, which is what makes this kind of peat-like soil, which is actually really rich and nutritious and really good for plant growth. So here we have just a little table kind of summarising the effects on flows and stores for carbon Temperature particularly freezes the carbon into permafrost. As climate change changes that, it will warm a little bit and that carbon will start to be released. Vegetation, it's very little biomass here. What is there is a bit like heather. So it's not a big carbon store, it's relatively small. But as we get warming and temperatures changing, that will increase. So the current low levels of photosynthesis and respiration will change in the future. Organic soil matter, good store. It's really good store of soil organic matter that's taken long time to decompose. As that thaws, it will start to release carbon and that will change. And the rock composition, very low levels of carbonate because poor organic stores. And it takes a long time for weathering and soils to develop. There are some seasonal variations. Most of the year, this region, this tundra region, for 10 months will have cold conditions below freezing. The land will be covered with snow. But for 2 or 3 months of the year, temperatures will rise above freezing, the snow will melt away, and you end up with this kind of boggy wetland environment. So there's a big change between winter and summer for the water cycle, between frozen in the winter and lots of flows as it melts into the summer. If you're looking at the carbon cycle, very little happens in the winter, but in summer when the active layer melts, that's when plants can grow and can photosynthesize and respire, even though it is at a limited rate. These areas, these beautiful areas, are very sensitive, but there are human activities taking place. There's a lot of restrictions in terms of visiting, etc., but these do have oil and gas. If you have studied glaciation or oceans, you will know that Alaska, particularly off its northern shore, has offshore deposits of oil and gas, and that has led to the development of the Trans-Alaskan Pipeline and issues associated with flaring of the gas and the transportation of the oil. So human activity does take place here, and it has some consequences. That human activity raises the temperature. It has led to melting of the permafrost. That melting of the permafrost in turn has led to issues such as drunken forests, such as subsidence, such as methane release. And they are having consequences, particularly the methane release, is generating feedback loops. It has altered the drainage. The human activity has altered the melting, which areas melt and how those areas are drained. It's led to issues like water pollution and also changes in the rate of evaporation, much higher rates of evaporation because of these warmer conditions. What has that done to the carbon cycle? Well, as the permafrost melts, it releases carbon, both in the form of carbon dioxide and methane, which triggers those feedback loops, which makes the environment warmer. And that's actually going to have a global effect, not just a local one. We have had a loss of vegetation, so that reduces the rate of carbon uptake and photosynthesis, even though it's slow already. There is combustion, particularly flaring, that is putting CO2 into the atmosphere rather than keeping it locked up in the soil. And the soil is becoming disturbed as the active layer thaws, and those summer months are becoming longer, 3-4 months because of climate change. That is changing the soil. The soil is becoming disassociated with the permafrost above it. You're getting it to kind of slide around a little bit. You're getting soil creep taking place and other problems associated with that. With this in the previous slide, you need to think a little bit about the impacts. Are they just local to your case study or to tundra regions, or do they have global impacts? Which is more significant, the local or the global impacts? How long lasting? Are they short or long term? And then finally, we've got a whole range of strategies. Feel free to pause the video on this and have a little look through them. They do have strengths and weaknesses, and again, this is good for your AO2 analysis that you need to include if you're writing an essay or doing a 10-mark question. So you do need to think a little bit about it. And again, this synoptically links to glaciations and oceans. So do go back particularly and have a look at your glaciation notes and the Trans-Alaskan pipeline. But there are things that are being done to try and reduce the impact of human activity, but it won't stop it totally. So feel free to pause the video and have a look at some of these management techniques. Well, thanks for listening. Pause the video. You've got key question 2B here and some key points that are covered in it. Put green if you get it, amber if you need to review, red if you're really not sure and need to ask for help. Thanks for listening.